Chapter 2, starting stats, after we get all the vocabulary out of the way in Chapter 1.
So this is like actual math?
Kind of. The first two sections we're going to, first two sections we're going to go over all ways to graph this data. So you've got all this piles of data, how do you want to display it? So today is all about organizing your data. And usually before you make a graph, you'll put it into some kind of a table to organize it. And the table we're going to use is called a frequency distribution. So frequency distribution. Doesn't sound like it would be a table, but it is. It's a 2-column table. A 2-column table that shows the classes, and I'll explain what that means, of data, and the frequency, which they use F, for each class. It's a 4-step process to making a frequency distribution. There's 4 steps to making this table. Frequency, that's going to be the letter. So when you see F, it's going to stand for frequency. Frequency is how many total amount. Okay, so the first thing you're going to do is decide how many classes you want to divide your data up into. And if you were doing your own study, you decide how divided up you want it to be. For the problems in the book, they tell you how many classes. So you decide on the number of classes you want. That'll be how many rows you have in your table. And that's going to be our letter N. After that, you calculate the class width. And to do that, you take your maximum value, subtract your minimum value, divide by the number of classes. Most often, this will come out a decimal number. Very seldom is it going to come out a whole number. You won't get that lucky to get a whole number here. So when it comes out a decimal number, we need the class width to be a whole number. So you always round up. Up to the next whole number. If you get a decimal. Yep. Even if it's 2.058, you round up to 3. Yes. Otherwise, when we make our table, your last value in your table will not include the last value of your data. It won't be, your class width won't be big enough to include the highest number in your set. I'll show you that when we get there. Okay. After that, you make your 2-column table. So column 1 will be your class limits, and I'll show you those. And then column 2 is going to be the frequency. Okay, so now we need some data so we can make a frequency distribution. And we're going to go with a nice big data set to start with. You need your book open, and you need your calculator. Frequency. Right here. You want to be on page 20, nope, 20, this one over here, where you've been. Yeah, it's page 28, but it's not marked on the bottom. Page 28, where you've been. Okay, so what they're giving us here, it says, for instance, the following represents census data. What does census mean again? It's the entire town. It's everything. So the census for this town, reporting the ages of the entire population of the 77 residents of Akiok, Alaska. So the whole town only has 77 people in it.
This is what I'm confused about. How do you know they're just asking about that? Like, obviously I know this one they're just asking about.
Right.
Like, if they just do of this town, how do you know their whole big picture isn't for the whole United States?
They almost have to, sometimes you need more information to say we're studying this, to say something about the beyond this realm.
So if it just says that, then it's just...
Yeah,
that.
right. So we're going to organize these ages into a frequency distribution. So what we're going to use is our handy dandy calculator. I'll get mine going here. You're going to find things on the calculator you've never seen before. Turn this on. We're going to put these all in a list, and we'd like to have them in order, probably from youngest to oldest, and I'll show you how to do that. Everybody ready? Okay. Everybody ready? Stay with me on this stuff because you get lost right away and it takes forever. Press your stat button right here. We have got to put our data in first. So we want to edit, number 1. Okay, I have numbers in list. You may or may not have numbers in list.
How do I get over?
What?
I'm on L5.
You just use your left arrow. Do you have any? Somebody may have deleted them. Bring it up here and I'll get them back. Actually, know how you do it. Press stat. Press stat again. Go down to number 5, set up editor, and hit enter.
Done.
Now go back to stat and number 1, edit.
Okay, thank you.
Yep. Okay. If you have numbers in the list, you need to clear them out. So I need to clear these out. So I'm going to use my arrow up and get on L1. So if you have numbers, do this. Now if I hit clear, clear is right here. Nothing happens until I hit enter. And it clears them all out. So you'll be doing that soon enough if you had it, if yours was empty right now. Okay. Now, yeah, you can clear them all if you want. We don't need them. Clear. All right. Now it's just data entry. You're going to type all these ages into the list. 28, enter. 6, enter. 17, enter. Yeah, good luck.
You have to do all of those in one?
77 of them into L1.
Wow. I mean,
Yeah.
like a book.
I mean, this is probably the biggest data set we'll have. You know, the rest of them will be like 10, 12 pieces of data or something, but we'll do one big one.
Yeah.
And there'll be somebody who does it, screws it up. Guaranteed.
You just go and get it over with.
Oops. Me.
Why did you do this? Oh my god. How do I delete an entry?
Go back on it and type over it or hit delete.
I wasn't me. That was an entry.
You're good.
Rub it in, Matt. Casey, keep
I
going.
keep typing in 22, but I'm still typing in 2.
How is somebody 0?
They're probably rounding if they're like maybe 1 month old or 2 months old.
Yeah,
Oh,
because
they're
it's
supposed
supposed
to
up,
round
George.
up.
No, on class width. These are not class width, these are ages. Geez, you take everything I say and apply it to everything? I don't think so.
Yeah, God forbid.
And then we don't apply it to something and it's like,
Yeah.
well, why don't
Class
why
width
does this
only.
happening?
This rule only applies when we do class width. You know, we haven't done class width yet. Okay.
All right, I'm good.
No.
So after, if you check, after you hit enter on the last one, see down here it says L178. My cursor is sitting on the 78th entry. That means when I go up to my last one, I did put 77 numbers in, so I didn't miss anybody. So when I'm down here though, there's nothing there, so it's all good.
I can't see this thing.
Well, it's just a list of numbers, there's nothing to see.
Well, I know, but what
Oh.
it does.
Okay, but we're going to check to see. We're going to have the we're just going to have the calculator add all these numbers up. And if everybody gets the same sum, we probably all typed in the right numbers. But if you get a different number than what I get, then you were probably wrong and I'm probably right. So that's the way we're going to go with that. Everybody ready to check yet?
Yes.
Oh, we got slow data entry. You're going to lose your minimum wage job over there.
I don't have a job. I like your tie.
She just has a kiss in the first place.
She thought you were just gonna immediately insult her. You learn after a little while.
Okay.
Okay, now I want you to quit and get out of this list. Those numbers will be there until you delete them. Quit is right here above the mode key. So go second quit. Okay, clear out. Okay, I want you to press list, which is right above the stat key in yellow. So you're pressing second stat to get to list, or whatever. You go over to math.
Math.
Alright, so we're doing math.
Number 5 is sum. Now you've got to tell it which list you want it to sum up.
L1.
And if you look right above the 1 key, you'll see L1 there. So you want to go second, number 1, and hit enter. My ages add up to 1,705.
Mine says 1,745.
Me too.
Yeah, I got
Yeah, I
45.
got 745.
Oh, I'm wrong?
I got
1745? 55, you're wrong then, I'm wrong.
45.
We got lots of 45s? Okay, so mine's wrong.
I was sorry.
Yeah,
What were you doing?
wrong.
So I'm moving on, you gotta stay with me.
What button did we
I
press?
got 1745.
Everybody got 1745 but me. That's the first time I've gotten this wrong.
I got 1950.
Probably because I'm sitting down, I don't know, blame it on something.
What did we do?
Probably because you said you were right.
Yeah, I was all confident.
Add them all.
Why?
Yeah.
So we could see if everybody has the right data, same data.
Why did this happen?
Well, yeah, but why didn't we just?
Why did it go in there?
28.
Because you were listening on your phone. You were showing somebody something on your phone when I was giving the directions.
I did it right.
No, you didn't, obviously. Matt, let me see your calculator.
I got 1745.
No, when we're working with calculators, you need to, I'm not,
Okay, no.
let's see, I need my other one.
How do I do this?
You missed a vital step by showing your phone to someone. Vital.
List, math,
Oh, I can't find my little, oh, it's in this one.
you're doing sum, 5.
All right, Matt, give me yours.
So I'm here, and then I just go to the L1.
Nope,
right?
you missed the vital first step. Link, list.
Short two, quick
L one.
snowplow going on.
Two and, yeah.
Oh, why did I get an error? Oh, because this one doesn't transfer, that's why. This port's wore out on this one because I used it so many times. We'll just go with your data then. You'll have to tell me. Okay, so that was just to check to see if everybody had the same numbers. I obviously do not. Like I said, our whole goal was to get them from youngest to oldest so that we can organize them in a table. So our next step is go back to stat. And Austin saw it earlier. We've got two sorts, sort A and sort D. What do you think they stand for?
That's a big jump. Add and divide.
No. How could you sort something?
That was actually a really good guess.
Alphabetically.
No, in numbers. These are numbers.
This,
High to low and low to high. What numbers could be A and D if I'm talking low to high and high to low? Think about a staircase.
elevator.
Ascending and descending.
Oh, wow.
Oh, ascending and descending. So what do we want? Ascending. We want to go up. We want to go low to high. So we're going to pick number 2 and tell it to sort L1 again.
Says done. It didn't
Done. So now we want to see them. So we'll go back to stat and just press number 1 like you're going to edit it, but we're not. We're just going to look at them. So now they are all in order.
Wow.
All right.
That's pretty impressive.
That's impressive. So we've got our data in there. We have to decide on the number of classes. We are going to go with 6 classes. I'm going to get my notes back out. So we want to have the ages broken up into 6 from 0 to whatever and have 6 of those divisions. So we're going to have 6 classes. So we'll call this example. I need a whole new sheet for this. Example 1 we're making. We're going to go with 6 classes. So our first thing we're going to do after that is find the class width. The width. That's how many ages are you going to put in the first group, how many ages are you going to include in the second group, third, fourth, and fifth. And they all have to be evenly sized. So we're going to figure out what that class width has to be. Using our formula, we're going to take our max minus min and divide by the number of classes. So what was our oldest person in this town? Maximum age? Does anybody have it? 63? What was our youngest person? 0, that baby. That was probably a newborn or probably under 6 months old, so they're rounding down to 0. And then we're dividing that into 6 classes. So what's 63 divided by 6? 10.5. So we can't have a decimal as a class width, we have to have a whole number. Even if this was 10.1, what would our class width be?
11.
This is the only time you always round up. If you kept this, say this was 10.1 and you made it 10, when you go to make your table, your last age will not include the 63-year-old. He wouldn't fit in the table. That's why you always have to round up so you include everybody. So what that means, now we're ready to make our first column the class limits. So this table's going to grow. We're going to add on to these 2 columns afterwards. So start your table way to the left because we're going to add more columns to it as we go through the notes today. So our first column, though, are going to be our class limits. And because I got 11, I want the first 11 ages in this first class. So what's my youngest person? 0. What would the oldest person be that's my 11th age up?
11.
What?
Wait, what was the question?
12.
I want 11 ages included in here. Where do I have to stop? 10 is correct, because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0 to 10 includes 11 numbers. Do you agree that there's 11 values there?
You count 0.
So you count it. Yep. What is the next class going to start at? 11. Because we're ending at 10, the next one has to start at 11. Where is it going to stop at?
22.
Let's check. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Wow, and you
But
don't
11 plus 11 is...
Okay, so what's a way to remember what to do here?
Just add 10.
You could add 1 less than your class width, because what you're doing is you're starting at 0, and I'm going to add on 10 more. Or, the way I like to do it, if I know my class width, well, I would like to be the only one talking so you can pay attention and learn this. If it's 11, you start with your smallest one. If I add that number, I get the beginning value of the second class. And I can do it. So if this one starts at 11, I knew this one would stop at 10.
The next one's going to be 32 on the
So if I add 11 here,
22.
32,
No, it's supposed to be
No, the other way.
oh, 22, 22, which means that one would have ended at 21. I can add 11 here. It's gonna 32, and we just keep going. How far am I going to go? 6 groups. So keep adding 11 till I've got 6 rows in my table. So 22 will be 33, 44, 55, and then this will be. Do you know how to get these? Besides copying down what I write down?
No, you can trust me.
What? Sounds bad.
What's my last value going to be? 65. Not my oldest person, because everything, all the classes have to have that same width to them. Very uniform. Okay, so are you good with that? All right, now our second column is the frequency. And my definition was frequency was the number of values for that class. So what do you think we're going to do here?
Add them all up.
Count up. How many people in this town are from 0 to 10?
How do we know that, though?
You've got them in order on your calculator. You just count them.
Or if we go to the 10 and it's like L1, 25.
That tells you there was 25.
Okay.
And then you got to know what to do after that. It's a little bit trickier, but. And my data's wrong, so you're going to have to tell me. I didn't type them in right. So you're counting. Right now you're just counting. Let's see if I can find where my mistake was at.
I got 27.
I got 27 also. I was
Oh, 27?
10.
Oh, you didn't go to the last number 10.
No, I got it.
What?
Can you tell me what I'm counting on?
I got
How many people are from 0 to 10? And they're already in order,
including 10.
including the 10s,
I got
0s, there's
28.
10s. Where's your last 10 at? My last 10 is at 28.
Definitely 20.
Yeah.
But I'm wrong. Am I wrong or not?
Yeah.
27? Okay, so that's where I made my mistake is up there.
27.
Okay. So you're wrong. You must not have had the right sum either. That's 1745?
Well, I had last.
Yeah, you were wrong and I was wrong. Now you got to count your 11 to 22-year-olds. This is a little bit trickier.
Wait, how many tens is this supposed to be?
3, I'm wrong though. I've got 3 of them. Okay. How many 11 to 21-year-olds are there going to be?
13.
Okay, and this is just counting. You're just counting. I don't know how to teach counting, other than you got to know it. You got to know where these are coming from. Why don't you go through and count? Everybody count their own table, and then we'll compare. Then we'll know if you're doing them right. So you're just counting how many are in between these values.
Wait, what kind of graph is this for?
This is a frequency distributor. I'm not making a graph yet, just a table.
Oh,
We're going to make graphs off of the table afterwards, after we add a bunch of columns to our table. But I'm going to highlight this and say this is your frequency distribution.
that will help us with graphs.
Yes. And I'll show you. We're going to make like 5 different graphs off of these people here. Okay, what'd you get for the third class? How many were in there? How many 22 to 32-year-olds?
I got 15. I got 15.
It is supposed to be 16. The 33 to 43-year-olds? 7 is correct. Then,
11.
and then 3. Nope, because I've got my right data written down. If you didn't have that 1745, there was no way to get those numbers right. Okay, so what should the frequencies add up to? Yeah,
78.
77 people.
Yeah, 77.
Okay, these 2 columns right here, this is your frequency distribution. It's that 2-column table. Now, because of the graphs we're going to make later on, we're going to add to this table. We're going to
Down or sideways?
sideways. We're going to add 1, 2, 4 more columns to this table. Okay. So the next column we're going to add to this is the midpoint column. So we're going to find the middle. How do you find the middle of two numbers?
Add them up and you divide by how many there are.
Add and divide by 2, because I'm averaging the two endpoints. So what's 0 plus 10 divided by 2?
5. Oh, no, it's just 5.
It is a 5. You were thinking the 11. 11 plus 21 divided by 2.
2.
2?
What?
Try again.
Just kidding.
16. What's the difference from 5 to 16? And do you think it's a coincidence?
11.
11. Do you think that's a coincidence?
Well,
No, it's not a coincidence. Because these are all evenly spaced.
11 now?
You could just add 11. Once you find your first midpoint, you could just add your class width. Because they're going to be a class width apart. Because we made everything uniform in size. Or you can keep averaging. It doesn't matter to me. So what do we have for the next midpoint? 27.
38, 49, 60.
Okay. So midpoints are easy enough. Now we want relative frequency. It sounds bad, but wait till you see how easy it is. Relative frequency is just your percentage for that class. What percent of the town is from 0 to 10? What percent of the town is from 33 to 43? So it's just a percent, but they write it as a decimal. So what would we do here? How do I get the percent of this town that's between 0 and 10?
27
Divided by
5.
77.
77. 27 of the total 77 people. So I want to turn that into a percent. So it's the frequency divided by the total. So we'd have 27 divided by 77. And they do just usually write this in as like a 2 or 3 place decimal. So what percent of the town is in that age bracket? 35%, so 0.35. And here you're using regular rounding rules. You want to keep that percent as close to the actual percent as you can. So don't use that always round up rule every single time you got to round something. Only on class width.
Oh, I need 2 is great.
2 is good. Let's go with 2.
0.17.
0.1, so 17%. Next.
So it'd be 13 divided by 77.
Mm-hmm.
Next is 0.21.
21%.
You don't want us to actually write it as a percent?
Nope. But that's what you're finding. That'll help you remember what to do.
Next one is 0.09.
0.9. And then
Next one is 0.14.
and
Next one is 0.04.
are we good there? Okay. Next one is cumulative frequency.
Is this the last one?
There's 2 I said.
Oh.
4, total of 4. Cumulative frequency. What does cumulative mean?
A total of all.
Total. Cumulative frequencies. We've got a frequency column. What do you think we're going to be doing when we're doing cumulative frequencies?
We're gonna. Where's the
Total, you said. You're going to be adding.
Is there one more column?
So we've got 27 to start with for our first group. Now when I go to the second class, the 11 to 21-year-olds, I want the cumulative frequency. That means this class plus anything that was previous to it. So you're going to add the 27 and 13. Is a total of 40 people. When I go to the third class, I want to add that one plus what was previous to it.
40 plus 16,
Is
56,
56.
56,
Oh, I'm just adding the frequencies above it, Austin. Start with 27. Then when I go to the second class, I'm adding 27 and 13 for 40.
Oh.
Then when I go to the third class, I'm adding 27, 13, and 16.
Oh, okay.
And then I'm going to add all 4 of them for the fourth class. What did you get for the fourth one here?
63,
63. Then 74. And then, so it's kind of a self-check. The last one better equal your population or sample size, whatever you're working with.
Oh, that'd be frustrating if it didn't.
Mm-hmm. And then our last one are class boundaries.
Can you move over to paper, please?
Yep. Class boundaries. So we started with class limits. 0 to 10 are limits. Now we want class boundaries. What class boundaries do is they close the gap in here. Because if you think about a number line, so you don't have to write this down. 0 to 10, then it's a space of 1 to start at 11 to 21, and then 22 to 32. Okay, there's a gap here. I've got from 0 to 10, and then I start from 11 to 21. What I want to do is close this gap. So instead of ending at 10, I want to end at 10 and a half, and I want to have the other one start at 10 and a half. I want to save the 0 for a minute. So this first class boundary, the limit's 10, I'm going to bump it out to 10 and a half. The second class, instead of starting at 11, I'm going to back it up to meet that first class and have it start at 10 and a half. Where's it going to end at? 21.5. So that means the next one's going to start at 21.5. Where's that third one going to end at? 32.5. See what's happening? We're closing the gap. So then,
Is it 0?
Oh, okay, never mind.
Is
I get it now.
it 0 through 10.5?
no, I'm going to come back to that in a minute and explain why we're going to do what we're going to do. And then the next one is ending at 43.5, starting at 43.5.
Why didn't we just do this in the first place? I don't get it.
I don't know. Well, there's different graphs. You're going to see the different graphs. So some are going to use limits and some are going to use boundaries.
Okay.
To 54 and a half. And then 54 and a half. Now, you know how all the limits, they were exactly the same amount. They're the same width apart. We want to keep that same width going all the way through here. So where's this last one going to end at?
65.5.
65.5. Where would I start the first class at? Negative 0.5.
Oh.
Makes no sense for ages, but to keep the uniform width of all the classes, I got to back up a half. Rachel?
Okay, so, but if you round up, wouldn't it be like anything more than 10 to 22? Like,
What are we talking about? Ages being rounded up? What are we talking? I don't know what you mean.
you have to round up the ages? Like, if the ages, never mind.
Okay. Yeah, this is just to keep everything, you'll see when we make the graph that uses boundaries, these all have to be uniform in width. That's all that we're doing there, is keeping each class the same size. Okay, now the graphs that go with this. And there's a lot of them. Okay. Yep, we've got several graphs to make. We did. Those are the class boundaries. No, this is the starts here, ends here. It's a range of values. We're not actually doing any math.
Everything else is gonna be, like, cause we got 10.5 and we rounded up to 11, so for everything we get, it's gonna
No.
be, for every other graph or problem we do, it's gonna be a decimal that we found. Where did the 10.5 come from?
Where did this 10.5 come from? I needed to close the gap from the 10 to the 11 between these two classes. So I had to go halfway between them and have this one go out to 10 and a half and this one back up to 10 and a half. So now the first class ends where the second class begins. You want to close the gap between them. Because see, I went from 0 to 10 for the first group.
So it has nothing to do with the fact we got 10.5, like the 63 minus 0 divided by 6 is 10.5.
Oh yeah, nothing to do with that.
Oh.
Well, because we started at 0, that's why it's landing on that. They don't all start at 0 either. Your graphs will not, this happened to be, we had that young person. These numbers could start at, say, if they weren't ages, they're like 305 to 675. We have numbers in that range. So my smallest number would be here. Yeah, I kind of like the fact this one starts at 0, but that's okay. All right, let's make our graphs.
Wait, so technically, according to class boundaries, if you were at 10.5, you'd be in 2 different classes?
Nope, you'd be at 10.5, you probably would have rounded into the 11.
But
You would set those rules, if you were doing the study, I don't know how they do it, I'm sure they round to the nearest whole number, so using regular rounding rules, so you would have been here as an 11-year-old.
so I'm saying according to that class boundaries.
It's just going to give us the division between the two. So you could be right on the line.
How do we know if we're using condenser or class?
They're going to show you the graphs right now. The graphs are going to tell you what to use. Okay, so, and like I said, we've got like 5 different graphs here. First graph we're going to make,
Are they line graphs?
kind of, is a frequency histogram.
Better put our books away.
Yeah, because everything's on the table that you need. Frequency histogram, just a fancy word for, do you know what a histogram looks like? What shape it has? It's a bar graph. I know you've seen bar graphs before. And then with these, it matters what's on the axes. Your horizontal axis can be one of 2 things. You can use those class boundaries, or you could mark midpoints. Either one can be on the horizontal axis. On the vertical axis, well, the name of the graph kind of tells you what's going to be there. Frequency. So we're not going to get out graph paper and make them real technical. We're just going to do sketches right on our notebook here.
So the vertical axis is always frequency.
Yep, on a frequency histogram. So,
Will they like tell us which one to use?
well, it'll tell you which graph to make, and you get to pick. Let's do class boundaries, just because I think that's the more difficult one to use.
There's never going to be like a question like,
It's your response to everything. Okay.
what class is like 10.5 in?
No, not that. All right, so we need to, I'm going to go class boundaries. So my class boundaries are negative 0.5 to 10.5. I'm going to back this up a little bit. Like I said, it doesn't really matter. Negative 0.5, and I'll make my width here to 10.5. So you see this distance that I've established? Every bar is going to have that same width because we kept everything uniform in size. So my second class goes from 10.5 to 21.5. Next one goes 21.5 to 32.5. And then to 43.5. $54.5 and $65.5. So those are going to be the edges of my bars for my classes. And now I need the frequencies. My vertical axis is frequency. What's the highest number I need to get to? What's my tallest bar going to be? 27. So what do you want to count by? 5 wouldn't be bad. 3s I think would be better. Let's go 3s. 3, 6, 9, 12, 15, 18. Oh, I might be able to run into my stuff a little bit, but that's okay. 21, 24, 27. So we went by I went by 3, so you could go with it whatever you want.
Why are you going to 27?
Because that's our highest frequency, because I'm putting frequency on the vertical axis. So now we just make a bar for each of those classes. So we'll have 6 bars. So the first class went from negative 0.5 to 10.5, and there's 27 people in there.
24 to what?
We're making a bar for each one. The next group, from 10.5 to 21.5, what's that frequency? 13, so I got to estimate 13 here. The next one's up at 16. I mean, these are just, I mean, if we wanted technical graphs, technically we'd have a computer make them, but. And then the next one is at 7.
Just drawing buildings.
And then 11.
This is all one problem?
Mm-hmm.
How do you say that like it's normal?
And then 3. And there's a frequency histogram for the ages of the people in Akiak, Alaska.
That one lead till 63.
And frequency.
Yeah, do they just like die young? Do they get really old?
Well, think about Alaska. It's kind of rough up there. I think it's a good
Did you just write ages or what?
ages and frequency, yep.
Okay.
So we know what the axes are. We usually label.
I'm not move on yet, I'm not.
Okay.
Are we doing the homework now?
Are we doing another example?
I was going to make another graph, but we don't have time for all 4. I guess we can stop here and then let me see what I can give you. I can get you started. This will be enough to get you started. Make a few tables. I may change the directions that are in the book.
Literally the homework better be like 1 or 2 problems.
I don't know what the homework's going to be here. Let me see what I've got. Let's see.
Okay, let's not bring our hands out.
Let's see. Page 39. 1, 2, I don't even care about those. Midpoints, cumulative frequency. 6.
Ages. And then, yeah, you got frequency, it's just ages.
So is there like an answer?
That's the graph. The graph is we're making graphs.
Or you just never find an answer?
So there's not like a question, it's just...
No, display the information in a graph. So what it does is now that I can look at this, I can see there's a lot of younger people, and the older people die off pretty quickly. I mean, it shows you major decline here. The older you get, the less people that stay. Maybe they just move away. Who knows? Okay, you're going to do page 39.
Like, why are they not?
Number 5, you're going to add to the table that's there. So you're making a table like we just did. They've already given you the first 2 columns. They're asking you to add on
Wait, is this the assignment?
class boundaries, midpoint, and cumulative frequency. Then I want you to do number 7 and 8 is just looking at some graphs and answering questions. We didn't do that. We didn't do that. And I'll have you make a histogram for number 5. A frequency histogram. Make a frequency histo. So we're adding this on to number 5 because it doesn't say do that.
So when do we know when to do midpoints or class boundaries?
It's telling you to add those columns to your table in number
Well,
5.
I know, but for like the histogram, because it says the...
Frequency histogram is what I gave you, class boundaries or midpoints. You can do either one. I did boundaries. If I had done midpoints, I would just would have been in the middle of my bar. I would have put, what was my midpoint, 5? 16, and then made the bar go around the midpoint. It would be the exact same graph, except these red numbers would be gone, and the midpoints would be listed.
Okay.
So that's the only difference between the class boundaries that I did versus putting midpoints in. Oh, 16, sorry, 16.
Do we make that the midpoint of the graph as well, or like of the bar?
The midpoint of the class is the midpoint of the bar. Yes.
So we draw.
Yes. There would be the exact same graph with these numbers in them. What do you need, Axel? Yep. Yes, that's what that would look like.
What are you doing?
Thank you.
Okay. Good. I didn't make that point clear, so. Okay, there you go. Not too much.
Well, this person, 0, 8.